We're gonna revisit just using SOHCAHTOA or the primary trig ratios and solve for some sides and then some angles at the end. What we're doing here is we're solving to the nearest decimal point, which is pretty much what we would do. You need to get used to using your own calculator for this. Okay, pretty much every time we're gonna start the exact same way. I'm gonna label my hypotenuse. I'm then gonna label my opposite and my adjacent. So here, we're using the adjacent and the hypotenuse. Now remembering we have SOHCAHTOA. So if I have adjacent and hypotenuse, I'm going to be using cos. So for this question, we would have cos theta equals adjacent over hypotenuse. So I'd have cos 22 equals x over 7. We would get x equals 7 times cos 22. And when you plug this into your calculator, you should get x equals 6.5 centimeters. Same thing for the next one. Okay, we're looking here. We've got hypotenuse, got opposite, and we have adjacent. So here, we're using opposite and adjacent. So when I work through this one, I'll make a little line here. We've got tan theta equals opposite over adjacent. That's TOA of our SOHCAHTOA. So we have tan 57 equals x over 2. We get x equals 2 times tan 57. Okay, in my calculator, I need to push the tan 57 in first and then just multiply my answer by 2. So here I get 3.1 centimeters. Okay, looking at this next one, this is nice because it gives us all three different types. We've got, again, our hypotenuse is here, our opposite is here, and adjacent is there. So we've done cosine tan. Let's do sine now. So this is going to be sine theta equals opposite over hypotenuse. Then we're going to have sine 61 equals x over 17. We get x equals 17 times sine 61. And then we're going to get x is equal to 14.9 millimeters. Okay, when you're working on this next one, I want you to try D on your own. You're going to recognize that the rearrange isn't as easy as the first three. So you need to actually take your time, understand that we're just multiplying and dividing, and we need to isolate x by itself. Okay, let's look at finding the angle to the nearest degree. So if I were to look at this triangle, and this triangle has something unique about it. We've got our hypotenuse, we've got our opposite, this would be adjacent. So we're using these two sides. Okay, so that's opposite and hypotenuse. So we're gonna have sine theta equals opposite over hypotenuse. Well, that's gonna be sine x equals 15 over 10. And then we're gonna get x equals the sine inverse. Remember, we're undoing sine of 15 over 10. Now, when you type that into your calculator, you're going to get an error. Now, the reason that is what we have to recognize when we're doing these questions. The opposite has to be smaller. Has to be smaller than hypotenuse. Okay, we know that hypotenuse. We know that because there's the O. The hypotenuse is the longest side of a triangle. Okay, so when we're looking at this, we had 15 is bigger than 10. Well, that can't be true because 10 has to be the longest side. So this was never going to work. So this is an impossible triangle. So this triangle doesn't actually work out. So whenever you're doing these questions, if you ever recognize that your hypotenuse isn't the longest side, then you've either done a calculation error or the question's set up for you to write no answer. So you need to check that. You need to make sure that when you're doing this, your hypotenuse is always the longest side. Okay, when we look at this next one, we've got hypotenuse here, opposite and adjacent. We're dealing with adjacent and hypotenuse. Okay, I'm going to go back to blue just so our answers are always the same. So adjacent and hypotenuse is going to be cos. So we're gonna have cos theta equals adjacent over hypotenuse. We're gonna sub everything in. Cos x equals 12 over 35. And then we're undoing our cos. So remember, that's the shift button. It's the inverse of 12 over 35. And we get our x value to be 70 degrees. Here we are rounding to the nearest degree. Okay, we're always gonna round to the nearest tenth when we're doing a side length and the nearest degree when we're doing degrees. Let's try C and we'll take it up tomorrow.